We landed here in 1969. Why can't we do it now? 50 years of technological gap. Last January, the Peregrine lander tumbled through space just 24 hours after launch, its solar panels failing. Fuel leaking, NASA had to abandon its first lunar attempt in 52 years. 2 years earlier, the Artemis 1 rocket, meant to kickstart America's return, sat idle on the launch pad, defeated by a faulty engine. These aren't random failures. They're symptoms of a hidden crisis, lost technology that's crippling our return to the moon. Here's the paradox. We have 382 kilograms of moon rocks to prove we did this. But the knowledge to repeat it is vanishing. When the Cold War ended, the factories building lunar module heat shields shut down. The craftsmen who hand-welded propulsion parts retired, taking their skills with them. NASA's current engineers? They're staring at 1960s blueprints, trying to reverse engineer technology that was never designed for mass production. Even the spacesuits are gone, those worn by 12 Apollo astronauts now rot in museums, useless for modern missions. NASA just spent $3.5 billion to rebuild them from scratch, and they're still not ready. The problem goes deeper than blueprints. It's the ecosystem that made lunar landing possible. In the 1960s, 20,000 companies supplied Apollo, from wire manufacturers to precision machinists. Today, most are bankrupt or switched industries. When NASA tried to replace a simple bolt from the Apollo era, they found the original supplier closed in 1987. Worse, safety standards have evolved. Apollo astronauts flew in craft with just 200 safety tests. Today's Orion capsule undergoes 1,000 simulations, each weld scanned by CT. Environmental hearings alone delayed Artemis by 3 years. As Elon Musk put it, it's like Egyptians forgetting how to build pyramids. Money isn't the fix. NASA's Artemis program has burned through $90 billion, yet basic problems persist: heat shield erosion, corroded bolts. Why? Because we're not just rebuilding the past, we're trying to build something better. The original Apollo mission was a flag-planting stunt, costing $300 billion in today's dollars. Artemis aims for a permanent moon base, which needs sustainable technology Apollo never had. Compounding issues: global collaboration. Unlike Apollo's singular focus, Artemis relies on 14 countries, each with different standards, coordinating parts between Japan, Canada, and the U.S. has delayed the Lunar Gateway space station by 2 years. But there are glimmers of hope. 3D printing is reviving lost parts. NASA just printed a rocket engine nozzle using 1960s alloy formulas. The lunar laser reflectors left by Apollo, they still work, helping us refine modern navigation. And international science is filling gaps. When China studied its 1 gram of Apollo moon rock in 1978, they published 14 papers that NASA missed. Now those findings guide Artemis water ice exploration. This time, we're not racing for pride. We're racing to build something lasting using both old wisdom and new technology. NASA just pushed Artemis crewed landing to 2026. The question isn't if we'll return to the moon, it's whether we've learned to protect our technological heritage. Because the next time we plant a flag, we can't afford to forget how we got there.